Hi guys, so in this video I'm going to show you how you can scale your Node.js applications to handle twice the amount of users you would normally be able to handle by using the Node.js native cluster module, which will allow you to process requests in parallel. As you know, Node.js is a single threaded JavaScript runtime, so even if your computer has multiple CPUs, you won't be able to utilize all of them because Node.js will only run on a single thread. So in this video I'm going to show you how you can allow it to work on multiple threads. So what you need to do is first you need to set up a basic Express application. I have done so, and then I'll just start this application. And as you can see, the server has started, and next I'll load test it using a CLI known as load test. And if you want to know how I installed this, you can install it using the -g flag with npm. And if you're using yarn, you can also add it using this command. So after I've done that, if you do load test dash help, it will show you all of the commands which you can use, and if you get a message like this means that you have successfully installed load test. So what we can do is, first of all, we will say the number of requests that we want to have is 1000 requests, and the number of the concurrency we want is 100. So this means that it will run for 10 seconds and it will send 100 requests per second to our server, and then we just have to pass the URL for our application. In this case it's localhost 4000 because I'm running it on port 4000. And if we run this, it will send a number of requests, and as you can see, all the requests completed in 2 seconds. But this is a very simple application, so what I'll do is I'll just create a loop, and it will just keep on looping for 10 to the power 8 times, and this will, I think, take a lot more time because mostly you'll always have some database requests, or you'll also do something in a request, so this should also be accounted for. So after we do this, and we'll run load test again. Yeah guys, so as you can see, it took 83 seconds to complete 1000 requests because of this loop, and so this would take a lot of time if you deployed it to production. So what we need to do is we will use the native cluster module to process these requests in parallel. So the first thing that we need to do is we'll import the native cluster module. So for that, what we can do is we can say const cluster equal to require cluster, and we also need the operating system package to get the number of CPUs that we have in our system. If you want more details about the number of CPUs that you have in your system, what you can do is I just open a new terminal for the scaled application, and I'll say node, and what we can do is we can say require os dot CPUs, and what this will do is this will give you the information about all the CPUs that you have in your machine. So I have 4 cores, and so it will tell you more about that. And so what we'll do is we'll get the number of CPUs, os.c os.cpus.length, and here what we'll do is we'll say if cluster dot is master, where cluster is the this is the cluster which is the multi-threading package, and they've also given given how you can use this. So I think they have changed it to cluster dot is primary, but I'll use this master because this master is also another way you can do this. And then what you'll have to do is you'll have to loop for the number of CPUs that you have, and for all the CPUs you'll create a new process. Why are they not providing me with auto completion? Okay, okay, so I'll figure that out later. And next what we'll do is if it is not the master node and it is a worker node, we'll just put this statement here. And what I'll do is I'll also print out the port ID, and I'll convert this to backticks. And so this will give us the port ID, yeah, the process ID of the worker. And then I'll just restart my server. And as you can see, it started 4 times because I have 4 cores, and this is the process ID of each of the worker. And what I'll do is, after sending a message, I'll also send the process ID of the worker which is responding to this request. So what I'll do is I'll set process.pid, and I'll just start this again. And as you can see, the IDs change each time because each time a new worker node is provisioned. And now if I just make a request to localhost 4000, as you can see, this is the process ID is different every time because as you can see, these four are different process workers, and this one is again the same one. So cluster uses the round robin approach, which is the approach used by most cloud providers while you are provisioning load balancers. So I think it's a pretty efficient method. And now we'll test our Node.js applications to scale to many users. So there's another way we can improve our applications. So there is a event called cluster.onKill. So you can also kill your worker if you want to kill it, if you don't need it for some reason. You can say cluster.worker.kill. I think it's a small w. Yeah, so if you can use this to kill the worker. And there's also another method wherein you can do cluster.on exit. So when a cluster is killed, you get the worker, and then what you'll do is you'll say worker and worker dot process dot pid died, and you can create a new worker once a previous worker dies. So I'll just restart this server and I'll run this again. As you can see, we have the all the 4 CPUs working, and we'll again run this command, and then we'll see how much are this process finished, and it took a total of 57 seconds to finish. And as you can see in the previous example where this was not optimized, it took 83 seconds. So as you can see, this is a better approach because it processes the request in parallel, and there is just a very small amount of code that you need to write, and it's an overall great process to speed up your applications and find out what's the bottleneck which is reducing the speed of your servers. So yeah guys, if you like this video, don't forget to like, share and subscribe to the channel for more such content. Bye.